So today's lesson is about puzzle problems. And today we're going to use systems of equations to solve digit, age, and fraction problems. Let's go ahead and get started. So we have a technique that is used to solve these problems. And here are the 3 steps. Number 1, you will make a chart with more than one variable. Number 2, you're going to write 2 equations using the given information. And then we're going to solve using elimination. So go ahead and pause this video now. If you need more time, I'm going to move on. Before we get into the problems themselves, I want to talk about digit problems a little bit. These digit problems are going to be based on our number system, and I want you to look at these values below. So you have this chart, which you can fill in on your worksheet there. And if we have a number like 537, note that the hundreds digit is 5, the tens digit is 3, and the units digit is 7. Now that's not the actual value. The value of this number is 5 times 100, because it's the hundreds digit, plus 3 times 10, because it's a tens digit, plus 7 times 1, because it's the units digit. Add these together and you get 537. Same thing would happen with variables. If we have a number HTU, where H is the hundreds digit, T is the tens digit, and U is the units digit, you get H times 100 plus T times 10 plus U times 1. Okay, let's go ahead and look at example number 1. Go ahead and write this down. Pause if you need to. It says the sum of the digits in a 2-digit number is 12. The new number obtained when the digits are reversed is 36 more than the original. So find the original number. We're going to start all of these by making a chart. So here's what my chart is going to look like. I've got a number category, and I'm either going to have the original number or the reversed number. I've got the tens digit, the units digit, and the final value. So let's go ahead and look at this. I'm just going to say the tens digit, I'm going to call it T, and the units digit, I'm going to call U. Now the value is going to be 10 times T plus 1 times U, or just U there, 10T plus U. Now if I reverse the digits, I'm going to get U in the tens digit and T in the units digit, and my value is going to be, in this case, 10U plus T. Now we're going to take this information, we're going to take the facts above in our problem and write 2 equations. The first equation says that the sum of the digits in a 2-digit number is 12. So that says that T plus U equals 12. The tens digit plus the units digit equals 12. Now the new number obtained when the digits are reversed, that's 10U plus T, that means equals 36 more than the original number. Well, here's your original number, so we're going to add 36 to it. So here's that equation. 10U plus T, that's our reverse number, equals 10T plus U, that's our original, plus 36. Now I'm going to go ahead and simplify this a little bit, put both of my variables on the same side, and notice I have a common factor here of 9, and so I have U minus T equals 4. Now I'm kind of running out of room here, so I'm going to move some things over to the side here. You should have room on your paper there. I'm going to move this over here. U plus T equals 12. I just reversed the U and the T. I'm going to move this up right next to it. And look, I've got a natural elimination. Really easy. So I get 2U equals 16. And if I solve, I have U equals 8. Now, if I plug this U back into my original equation here, then I get T plus 8 equals 12. Of course, that means T equals 4. If I put them together, my number is going to be 48, is my original number. The reverse number, of course, is 84. Now here's a great time for the phrase of the day. Phrase of the day is a quote from Albert Einstein that says, "Imagination is more important than knowledge." Moving on to example 2. It is an age problem. And it says, go ahead and write this down. Sophia is 4 years older than Justin, but 5 years ago, she was twice as old as he was. Find their ages now. So we're going to set up a chart with the ages of Sophia and Justin. What are their ages now? And what are their ages 5 years ago? Well, we're going to use two variables here. So I'm going to say S is for Sophia, and J is for Justin. There it is. And 5 years ago, Sophia was S minus 5 years old. So whatever she is now, she's S. 5 years ago, she was S minus 5. Justin is J now. 5 years ago, he was J minus 5. Now again, we're going to use the facts in the problem above to write two equations. So it says Sophia is 4 years older than Justin. So that is S equals J plus 4. I'm going to rearrange this a little bit so that my variables are both on the same side. S minus J equals 4. Now the next sentence says 5 years ago, Sophia was twice as old as Justin was. So 5 years ago, that's S minus 5 equals twice, 2 times Justin's age. Now I'm going to simplify this a little bit and move the variable to the other side. Now I'm going to make two equations with two variables and use elimination to solve. Now I'm just going to multiply this top by -1, and it's not going to show up here, but you'll find out that J equals 9, and that would be Justin's age. Plugging that back into my original equation, S minus 9 equals 4. That says Sophia is 13. So Sophia is 13 and Justin is 9. One more example, example number 3. So we're working with fraction problems now. Go ahead and write this down as I read it. The numerator of a fraction is 3 less than the denominator. If the numerator and denominator are each increased by 1, the resulting fraction is 3/4. Find the original fraction. Just like before, we're going to start with a chart. And this time we just have these two columns here. Our names are our original fraction, and I have +1. That's when you increase by 1. So our original fraction is just going to be n over d, numerator over denominator. And you guessed it, if I add 1 to the numerator and denominator, I get n plus 1 over d plus 1. Same process where I'm going to use the facts above to write two equations. First one says the numerator is 3 less than the denominator. So I get n equals d minus 3. The second one says that if the numerator and denominator are each increased by 1, the value of the resulting fraction is 3/4. Well, that says that this fraction equals 3/4. Numerator plus 1 over denominator plus 1 equals 3/4. I'm going to do a little simplifying here. I'm going to cross multiply. It's going to help me out. And I'm running out of room, so I'm going to move my variable or my equations over here. So the first one, I just simplified it a little bit, and I get n minus d equals -3. I'm going to simplify the second one as well, put both variables on the same side. And I'm going to multiply the top one by -3, and that's going to eliminate my d's. And that says the numerators equal 8. If I plug that back into my original, that says d equals 11, and my original fraction would be 8 over 11.